All right, now we're going to take a look at the transformations combinations worksheet that you had to do for homework. You started with the function f of x. In the first problem, you have a horizontal compression. Well, you're multiplying by 1/2. You're really having a horizontal stretch by a factor of 2. So the point 1, 3 in your original function should map to 2, 3. Its x coordinate should double. The point 4, -3 should become 8, -3. Its x coordinate should double. And if we look at the answer sheet, that's exactly what happened. The point 1, 3 became 2, 3. The point 4, -3 became 8, -3. Now if we look at function b, we have an additional transformation. We're multiplying the y coordinate by 1/3. So a point like 1, 3, first, because of the horizontal stretch, becomes 2, 3. Then because of the vertical compression by a factor of 1/3, it becomes 2, 1 instead of 2, 3. Okay. Now let's look at problem C. We have a multiplication outside the function, which its effect is a reflection over the x-axis. So if I started with this point here, the point 2, -3, first I would reflect it over the x-axis. It becomes the point 2, +3. Now I have to compress it, use the horizontal shift by a factor of 2, so it becomes 4, +3. Now I apply the vertical compression of 1/3 and it becomes 4, +1. And the very last transformation has all of the original 3 transformations in order, and the last piece, this -2, means that this point, for example, moves 2 places to the right. Now let's look at the second problem that you needed to do. Let's look at the original worksheet first, though, and not the answer key. Here it is. All right, let's go to the next problem. We've got a bunch of transformations going on here. So let's just trace the path of one point. Let's just trace this point here. This is the point 6, 2. The first transformation tells us to multiply the y coordinate by 2. So this point becomes the point 6, 4. Now we're looking at this transformation here, which reflects over the y-axis. So the point 6, 4 becomes the point -6, 4. Okay. Now we're going to apply this transformation here. We're multiplying by -3 here, so we're going to actually compress by a factor of 1/3 horizontally. So this point -6, 4 becomes -2, 4, because 6 divided by 3 is 2. Now we're going to apply this transformation here, which means we need to move our point 3 places to the left. 1, 2, 3. And the very last transformation, -4, is a subtraction outside the function. It affects the vertical shift. We're going to move our graph down 4. 1, 2, 3, 4. So we have many transformations going on here. If we look at the answer key, we can see exactly in the order we did them. First we dilated or multiplied in a vertical direction by a factor of 2. Then we reflected over the y-axis. Then we compressed horizontally by a factor of 1/3. Then we shifted horizontally by 3 to the left, and then we shifted vertically 4 down. And that's the transformations that were happening in that problem. Let's look at the next problem. My original version is sort of messed up here, so I'm going to look only at the answer key. If we started with this function here in dark blue, h of x is the square root of x, and we apply the transformation h of x equals, we're going to apply the transformation q equals h of 2x. We are multiplying inside the function. Therefore, we have a horizontal stretch or shrink In fact, we have a shrink by a factor of 1/2. This means that each of the x coordinates is multiplied by 1/2. So if I were to look at the point 4, 2, it becomes, with the x coordinate multiplied by 1/2, it becomes 2, 2. If I were to look at the point 9, 9, 3, and I were to multiply the x coordinate by 1/2, I would have the point 4.5, 3. Okay, that's the first transformation. If I look here at r, it's saying to take negative h of 2x. This is a reflection over the x-axis because this multiplying by -1 happened outside the function. Therefore, this graph in brown reflects over the x-axis and becomes this graph in blue. The next transformation looks like it's occurring here in graph S. I am now taking my y values and multiplying the y values in this function r and multiplying them by 3. So if I look here at the point 2, -2, it becomes the point 2, -6. Now, the remaining transformation is one more transformation here. Is the only transformation left is this transformation, a horizontal shift by 3. So this pink graph here with a point 2, -6 becomes the point 5, -6, this particular point that I'm mapping or tracing. And that's really pretty much what's going on in this graph. If I look at the very last problem on this worksheet, I have here the graph f of x equals x cubed and 4 other cubic functions, g, h, k, and m, each one a transformation of the one above it, before it, in order that we could graph r of x equals -1/2 times 2 times x minus 6 cubed plus 8. So what would we really be doing here? It looks like the very first transformation we would apply is to reflect our graph over the x-axis. So, or Mr. Peabody thinks that I should multiply by 1/2 first. It doesn't really matter. So if I do a horizontal compression by a factor of 1/2, then the y values are going to be multiplied by 1/2. So if I were to take the point 2, 8 on my initial function, it is now going to be the point 2, 3. All right, because 2, 4. Because 8 times 1/2 is 4. If I were to take the point 1, 3, 27, I would now have the point 3, 13.5, which is approximately what I have. So there's a compression multiplying by 1/2. The next transformation is to reflect over the y-axis because of this multiplication by -1. If I look here, this transformation now becomes h of x, the one in blue, and a point like 2, 4 became the point 2, -4. And my point 3 and 13.5 become sort of 2 and 3, -13.5 in this h graph, which is in blue. Okay. So if I look at the original problem again, I have done the negative and I have done the 1/2. The next transformation I want to apply is this transformation where I multiply by 2. And that creates a horizontal compression by a factor of 1/2. So that my point here, which was at 2, -4, should become 1, -4. I don't know what he's doing here. Whoops, let's go back. Yeah. So that the point 2, -4 should become 1, -4 because of this multiplication by 2. Now I'm going to shift my graph 6 to the right, and I'm going to shift it 8 up. And that's really the sum total of all the transformations. I think what he was asking for was actually for us to give a graph, give answers stating what transformations had already been made, and express the answer in this form, and I was sort of plowing ahead doing this problem. So, but if we look at what went on in his example, the graph in black was x cubed, and the point 2, 8 became the point 2, 4. That's the first transformation, so there was a multiplication by 1/2 outside the function. 2, 4 became 2, -4, so there was a multiplication by -1 outside the function. And then this whole graph in blue shifted 2 to the right, so there was a subtraction of 2 inside the function. And that really pretty much explains this worksheet, and I hope that this helps you.